I think we're back. So I would like to thank you all for sticking around. It's actually interesting to reflect. I mean, the problem of the built environment is truly the paradigm of the blind people and the elephant, right? Everybody approaches a problem in different ways. You see a demand response problem, you see a thermal comfort problem, you see a construction problem, and all of them are true. So I hope that by the end of this, all of us will be a little bit less blind, and I would like to start the panel discussion with the three of my esteemed colleagues. I will introduce them very briefly, one at a time, starting with Professor Alberto San Giovanni Vicentelli, my colleague for many years at the Department of EECS at UC Berkeley. Alberto, your thoughts?
Thank you very much, Costa. So my presentation today is about some of the work that I've been doing in trying to apply some of the methodology that we have been working with in the electronic domain to the construction domain. So we have been talking about digital revolution in all aspects of engineering, but in construction, if you look at the state of the industry, we are still far away from having a digital methodology for buildings. So our vision was to develop a new methodology and the tools, of course, and models and materials for accelerating fundamentally the development of real estate assets. So the goal is to go from a 6-month process from building design to people occupation. So right now, if you look at data that have been provided by a company I'm working very closely with, it's called Lendlease, a large developer. This process takes multiple years. So sometimes 2 years, sometimes 3 years. And so to go down to 6 months is a major endeavor. Now, how do we try to do that? Well, if you look at one of the key elements of the methodology that has been used in the integrated circuit domain is IP-based design. What does that mean? It means that you are building complex chips by including components that have been pre-designed and are part of the library. So you can have a configurable process core, you add memories of various type and kind, special purpose standard blocks, and then you have glue logic, and then you put it all together with MEMS and other interfaces, and off you go, you have a product. Now, if you look at large companies like Apple, Microsoft, Amazon, Google, that they never design an integrated circuit, now they're all designing these components, so much so that for the electronic design automation industry, they become the largest customers. How is that possible? Because of the use of this methodology that allows them, for example, Apple has developed a very large chip, it's called the Monster chip, with more than 4 billion transistors. When we started developing methodologies for designing chips, we were able to put together maybe 100 transistors. Now from 100 to 4 billion, we have gone a long way. So is there something that we learn from this domain that we can apply to the building industry? Now, the point is that in the building industry, you have to go through an architect, and the architect is designing the shape of the building and is making it nice to look at. And if you want to make it cheap, you have to use the same design all over again, completely the same. And that, of course, is not very appealing if you're trying to develop a top-of-the-line building. So what we have been able to do in the electronic domain is to do a mass production of one, which means you are a unique building, but the way in which you put it together and the way in which you design it is actually typical of a mass production. So you use always the same pieces with the same method to assemble the various pieces. So that's the goal that I think is very important for the industry, is to develop a digital technology platform that will allow this transition from multi-year to 6 months. Now, in addition, you want this methodology to apply not only to the construction of the envelope of the building, of the floors, of the rooms, and the hardware part of the building, but also all the systems that support the life of the building and then make it a smart building. So in order to be able to do that, we have to develop a rich library of building components. So you have to find what is essential to construct a building which looks different, but is made of the same parts. So to find the actual components that will allow you to do so, and at the same time will allow you to assemble various parts correct by construction, is still a substantial effort, and is even questionable if we will ever be able to do so. I think that there is enough momentum behind the attempt to reduce the cost of construction that this may very well be a feasible methodology. Now, of course, like in electronic design, you have the library has to be validated and proven correct. So you have, because otherwise, when you assemble various components, you don't know if the building is standing up or is going to fall down. Now, of course, one of these issues can be resolved if you do a simulation, if you like, or verification in the early stage of a design, which brings then the concept that has been so much discussed, even in the building domain, of digital twins. And digital twins is nothing but a virtual model of what you are going to construct, upon which you can perform tests to see if, in effect, what you're doing is correct or not. So, in fact, the challenges are formidable, but the potential payoff is very large. And so, because the payoff is very large, that is where the smart money goes. So, there is a chance of being able to develop such a thing. So, the fundamental tenets of this approach is to limit or eliminate any on-site works with specific focus on what they call wet trades. And you want to improve safety and quality while you are developing these novel buildings. Now, of course, the kits of parts, and this is the connection between the design and the manufacturing of the building. Now, if you look at the electronic industry, that connection has been essential to be able to reduce the design time by a factor of thousands from the beginning of the technology to where we are now. Is the tight connection between design and manufacturing and the seamless translation from one to the other. So this requires, of course, these are big objects. So how do you form these components? And the idea is to make it in a specialized manufacturing plant and then transport these components to the site where you're going to make the building and then connect them up on site. And so, of course, to be able to do that, you have to pre-certify the components. And then you also can study the components in such a way that they are much more robust than what we have today, because they can be pre-tested and pre-analyzed and pre-optimized. Now, the additional advantage of basic tenets of the methodology is the fact that you can embed into this methodology also the idea of using renewable components and to limit the waste of material. You also want to make the building so that it's adaptable over time. So this one is another part of a smart building that self-adjusts according to the health of its components and to the needs of the people who are going to be in the building itself. And so, of course, the reduction of interfaces between various components of the building, meaning the construction part of the building, but also what goes inside the building, which is lighting, power, water, air, pipes, and so on, is a very expensive proposition today. But if we can indeed develop such a methodology, it's going to be much simpler to verify and much cheaper. So indeed, as I mentioned you before, I'm working very close to a industrial entity, which is called a Lend-Lease. And in fact, Lend-Lease has started a new division, which is called Lend-Lease Digital, where this methodology is being put to bear. And the idea is to make it also available for the entire supply chain. One of the big issues of the construction industry is that the supply chain is extremely fragmented, that makes the adoption of this kind of methodology very difficult, unless you build all the infrastructure so that the supply chain can share standards so that this composition of components can be done seamlessly. Now, of course, in all of this, I mentioned that digital twin is an important technology. And digital twin is another way of saying that you want to do simulation, and simulation or digital twin testing is key for faster building design. But unfortunately, the computational complexity is very high if you use detailed models. So you have to build layer of abstraction, and you have to understand what this layer of abstraction relationship are. But not only, but you may want to use data-driven models or a combination of physical and data-driven so that the complexity goes down on the verification step. So we heard before the speaker just before the panel that C3 AI has a bag of tricks that can help in constructing digital twins to support this methodology, of course, together with many other applications. So these are my initial thoughts. Thank you very much for your attention.
Thank you, Alberto. Indeed, a disciplined, scalable, provable design methodology is a must. And so I hope that you can elaborate a little bit further on the discussion. I would like now to turn it to our colleague, Alejandro Dominquez-Garcia. Dominquez-Garcia, he's a professor at the Department of Electrocomputer Engineering at the University of Illinois, Urbana-Champaign. And I believe, Alejandro, you're going to be talking about data-driven coordination of distributed energy resources. So your thoughts on that?
So the one thing that I would like to start by focusing on is that renewable-based power generation, which is being integrated into the grid, it's key for decarbonizing the electricity sector, right? However, renewable-based generation, when you integrate it both at the transmission level and also at the distribution level, including the grid edge, poses additional operational challenges. So one of them is that you basically need to be taking into account the fact that you are going to be removing generators from the system. So as renewable-based generation increases, so that means that you're going to be removing resources that were providing frequency regulation. So that's at the bulk level. And then at the distribution level, you might have issues of voltage control, etc. It turns out that there are many resources at the grid edge that could be utilized to potentially address these issues posed by the integration of renewables. So for example, you could have small generators at the distribution level that, if coordinated properly, they could be providing the frequency regulation that large generators were providing before, and so on and so forth, right? So in general, we call all those small resources distributed energy resources. And like I said, they are being integrated at the grid edge, many times behind the meter and so on. And those resources, if they are coordinated properly, for example, by an aggregator, they could provide the services that I was mentioning. Other DERs include electric vehicles, fuel cells, residential storage, and so on. The other thing that you could utilize also to provide these services are the buildings themselves. And there was some talk earlier in the workshop about optimizing the set points of HVAC systems, and so on. So you could use a building itself to provide these regulation services by modulating the power that the HVAC system consumes, okay? And the idea is that because of the thermal inertia you have in the building behaves basically as an energy storage device, right? So you can think of it as a virtual battery itself. So you know that's another resource that you could have to account for this. The challenge here is that in order to develop these schemes to coordinate all these distributed energy resources, you typically need models of the system you're trying to control, right? But this is very hard to get these models at the distribution level, and even if you are talking inside the buildings, because you know it's hard to build. You don't have data defining them or whatnot. So it's much better to rely on measurements that could allow you to develop those models, and then you use them for control tasks. So I'm going to stop there. Those are my opening remarks for this.
Thank you so much, Alejandro. Indeed, that's a very challenging topic, and contrasted to what Alberto had to say, that also highlights the diversity. But let's continue with Carl Gunter. Carl is also at the University of Illinois at Urbana-Champaign, a distinguished professor in engineering and computer science. So Carl, your thoughts?
All right, so I'll talk about privacy and security challenges, focusing on residential facilities. So let's see, at the current time, we have a great sophistication through the use of cookies to track user visits to websites and to track and make inferences from web searches. And then there is, following on that, GPS that tracks physical outdoor movements of users. And we have exploited a lot of what can be obtained from just these sources of information. And so I think a major trend we will expect to see then is Internet of Things or sensors in the home environment that track user activities there. Okay, and so this entails many, old familiar issues from the security and privacy that you would see, for example, in industrial facilities, but also kind of brings up some new issues, particularly the procurement and management of the systems will be carried out primarily by homeowners. And so this has a lot of implications in terms of the sophistication that they'll bring to the security considerations of the equipment that they have to deal with, and many risks, for example, of misconfiguration. All right, now, so what is the threat really? So this is a kind of nascent area where I don't think that we have a very good record yet of what we should be worrying about in terms of, we can conjecture things, but it's not clear yet whether those are real threats or not. And so I broke them down into three categories and wanted to offer as my 5-minute initial comment here, at least some thoughts on where I think the main issues lie. Okay, so first off, you think of the person who manages the system and in whose house the equipment is placed is directly attacked by cyber criminals. And so what you could steal that way is maybe not very much, but there's a possibility now of the system being exploited by extortion to monetize the attacks. So in particular, you would use cryptocurrency in order to get money. And so the issue there becomes scalability, but people have worked on that. So they have attacks that work with ordinary consumers, and then they provide the consumers a help desk in order to make their crypto payments for extortion. And they can raise money in this way. And so if you had a substantial number of people that you could get effective attacks on them, then you may be able to make large-scale monetization of that, especially given the kind of monitors in the home might have particularly private data, such as camera feeds. Now, a second possibility is that what you need to worry about is collateral damage arising from events in a broader context. In other words, they're not specifically attacking you because you have an asset that they want to steal, but you're caught up in a bigger picture. And so this has already begun to happen. The Mirai botnet is an example of that, which used IoT devices for denial of service attacks so they could collect devices that were misconfigured, easy targets, in thousands of homes. And so here we see the impact of the consumer being the one responsible for the configuration, because in this case, they did not, for example, set careful passwords, but it also goes hand in hand with expectations on the vendors who had often default passwords, firmware that was never updated, and so on. Now, a third possibility is that of vendor overreach in seeking to monetize the information collected from the homes, okay? And here, this is, for many of these companies, this is the motive for which puts them in the business. That is, the information they'll be able to collect that will help them develop better models that will offer things that they can sell that will perform better than something that has no training and no experience with data. So this is the application of AI in this space. Okay, and so the landscape here is one in which the homeowners are unable to practically assess the complex contracts that accompany their home IoT procurements. So many of these things have literally hundreds of contracts you would have to study in order to understand the full implications of what you're offering to allow them to do. And they're getting increasingly complex. An example of that is sometimes quoted is Roomba was looking at an idea of attaching some sort of sensor that would allow the device to map your home. And then that could be uploaded to the web to go into a library of homes. And so then, maybe you have your you can pick from those designs for various purposes, or use them for like general background information on how better, to design the next generation of robots to, live in the kinds of houses you're having seen. Okay, now at the same time that this is really beyond the customer's ability to understand, there's very little regulation that's taken place in the space. And so that consumers often would rely on some sort of protection at a basic level so that they didn't know that it sank below a certain degree. And this is largely missing here. And people are still very much in the mode of that we want to see what kind of innovation comes out of this and not freeze it with too much regulation. But on the other hand, it does go into a very private source and is very complex for the people who are going to have to look at it. So I formulated a few questions just to kind of, and I want to say, among the three, my vote would be strongly that vendor overreach is where your problem is going to lie. In other words, it's not hackers in the internet getting after you that are their biggest problem. Your biggest problem is buying devices by vendors that are going to collect them and sell them, and that you're going to experience, possibly without even appreciating it, harm from these kinds of cases going too far. Okay, I just want to end with three questions. This could be something the panel discuss if there is an interest. So one kind of key question I get out of this is how will the vendor market develop and what are the implications for development? So right now you have complex, unintegrated devices around the house. Maybe what we're headed towards is instead you have a Google house and I have a Samsung house. And so that the houses will be equipped, but more by a cooperating or a single vendor. Okay. And another problem here in this space is that it really very much brings up the issue of dealing with multiple stakeholders. So you have parents and children, tenants and landlords, and you have to deal with their differences of opinion and differences of concern. And so an example of a kind of thing here is, suppose you have a device that is used to monitor pipes to see that they don't burst, and the landlord wants to deploy that. Then the tenant may be worried about what kind of sensor equipment that is being put in their home and transmitted out to the landlord. And so coming up with trust models in which people can see eye to eye on the data collection within their home is a key goal. Okay, now, and then there are bits of legislation that are relevant to IoT. California Consumer Protection Act, or CCPA, and the European Union's GDPR legislation have relevance to IoT, but at this point, it seems that the full implications maybe have not been drawn as those laws are new and their adaptation is being put in question. So, okay, that's it for me.
Thank you very much, Carl. Yeah, last time I had to download an app on my iPhone. I had to scroll through 30 pages of this privacy contract, which of course I couldn't read and I didn't read, and most of us do the same. So privacy is very important, and the lack of regulation is very important. I would like to open it to everybody, so please raise your hand or put something in the chat. But I would like to follow up with a question to each one of Alberto, Alejandro, and Carl, and mostly tied it up to the other two presentations. For example, Alberto, you mentioned about standardizing the design of the physical assets that constitute the building, the design and streamlining the production. But as you go into the so-called smart buildings, the smart part of the building, this embedded system, is very important. And this embedded system will not only have to keep people comfortable and save energy, but also participate in distributed energy resources and demand response, protect privacy, submit to regulations. So could you reflect a little bit on how this platform-based design of that part could look like, and what are the challenges? Just very briefly.
Well, the challenge is essentially is a multi-vendor situation, right? Because you have, as Carl pointed out, you have several providers of a technology. So you may have Google with Nest, you may have the entertainment system that is somebody else, maybe Apple in the future. And the fact that you have to deploy all of this in such a way that the interfaces work is going to be challenging. So there is still an issue of interfaces, like in the physical construction. So try to find the way in which you can make this subsystem work with each other. But once you have the interfaces, then for each of the components, you can apply like a fractal, the same kind of approach. In fact, in some of the electronic domains, like for example, an automobile, platform-based design has been used both for the networking aspect inside the car and the construction of the car itself.
So modularization and APIs.
Right.
Essentially across a very diverse ecosystem that involves human interaction, involves policy, regulations, energy, and codes and building codes and so on. Yeah, no, that could be quite exciting. Yeah.
Yeah, no, because one of the key problems is that how do you make sure that all the regulations are actually followed? Now, if you have a methodology like this, you pre-certify with respect to the regulation, so that when you assemble the system, you are sure that everything is kind of correct, including the regulation.
So I see your question, Miriam, but let me pose two brief questions to Alejandro and Carl, and I'll get to you. Alejandro,
go ahead. Could I react to Alberto? I wanted
Absolutely. Go ahead.
I wanted to say
Absolutely.
something about how high the stakes are for getting this right. So there was a case, Target, the hacking of Target, was done through the HVAC system initially to get to the point of sale, and so a big impact on the credit card industry resulted, all originating in a building design system.
Right.
Yeah.
Right. And in fact,
any IoT system, any IoT-based system is very fragile. You know, the famous denial of service attack about a year ago was through the lighting system, right? So they enter into lamps, and then the lamps, every lamp in the entire state were submitting requests to the servers. So we have to do something at the periphery.
Let me just a quick question to Alejandro, and again, reflecting, Alejandro, you talk about data needed for distributed energy resources, and I would like to go to the point of data and the role they could play, not only in making automated design possible because it's a data-driven system, but also informing some other constraints like privacy and so on. Could you reflect a little bit on that? Because we seem to live a little bit in silos, right? We need data for our application, but data can serve many purposes. Just reflect on that.
Well, I mean, you could use privacy or diagnosis also. I mean, if there are like some issues, attacks on your system, etc., you definitely want to be measuring things to be able to pinpoint to where issues could be and detect problems, etc. And I guess privacy is one aspect of that. So, yeah, that's a good, very good, valid point.
Great, and a question to you, Carl. Actually, that's a reflecting what Miriam has typed on the chat. Could the policy makers be the unifying factor in creating some structure in all this? And what advice could we give them to make that possible?
You mean to like come up with policies for homes?
What I mean is this, is that we have such a diverse ecosystem, right? Designing commercial buildings, designing residential buildings, you have municipal codes, you have, codes at different levels. There is a whole mess of things. And what Alberto is talking about, I think he's talking about, is some standardization, modularization, standard APIs between physical and cyber systems will be needed in order to scale this up so you can design smart buildings efficiently. And I wonder, what will be the role of the policymakers in this? Will they just put obstacles, or could they do something more constructive and provide a framework?
Yeah, I think maybe a first step would be, I've seen a lot of regulations succeed from just aiding transparency. And so that you could have regulations that require information be made available. So an example of this is you bring a device into your home, it communicates to lots of different parties with no explanation as to what it's sending, and you have some fairly vague contract. And so if you had, some requirement that parties had to be able to see what type of data you're transmitting, then, parties, it might not hurt people's business interests too much to do that, but would give, an opportunity for analysis so that people could have more confidence and you might catch some things that are problems. So policy might go in that direction.
Quick follow-up on that, just my own curiosity. GDPR has been around now for a while and has spawned some, imitations, good imitations. California system, is essentially inspired from that. Has GDPR been seen as something that catalyzed new technology, or has it been seen as an inhibitor?
I think
that's a question to all of us, to all of you.
I'll say that in many areas, it seems like it's a catalyst. And you have some sort of framework within which to do analysis. And it's had some extremely positive effects. For example, some of the big American companies have gone over to GDPR compliance just to have uniform operations. And it's also good in these contexts to have something broad, so you're not too much mired in over specification of the systems. So like filling out the profiles for GDPR seems like a good agenda for kind of practical progress.
Yeah, I completely agree with that. I mean, if you look at the automotive industry, regulation is painful, but is actually a chance of innovation. So if you look at all the innovation before the electric vehicles, they came because of the regulation. And also in any industry whatsoever, if you have a standard that you design against or with, it's a unifying factor of the methodology. So it's mostly a regulation is an opportunity more than a impediment.
I completely agree with that, and not only that, but for example, if you are trying to ensure interoperability between different vendors and so on, regulation could inform how standards are designed, etc., which would actually accelerate that.
Very good. So I have some more questions. Again, the floor is always open if you want to type your question or you raise your hand. But going back in sequence, Alberto, you have submitted some questions before to me, and I appreciate that. But one question is that I like is that will the building design automation be doomed to being practical and fully scalable? And the crux of that is, maybe you want to reflect on that. Obviously, you hope it isn't the case, but maybe you can put some of the prerequisites that we need to meet in order to make it really practical and scalable. And what are the obstacles that you see today?
Yes. Well, the obstacle is fragmentation of the supply chain. It's very clear. And the fact that every building is an entirely new project, unfortunately. And there was a company that tried to go over it, was Caterra, and actually went bankruptcy, right? So, and the reason, in my opinion, is because they were trying to do pre-built houses and that nobody wanted to buy. They would look pretty ugly, right? So the point is that you want to keep the flexibility so that you can build any kind of building and at the same time use reusable components. So that is the real issue. But for example, in Australia, Lend-Lease was building a big complex. And they found out after, you push, you have to find something in common, blah, blah. And they had something like 50 different interfaces between components of the building. And after they started thinking along the line of this methodology, they came down to 6. And that simplified tremendously the design, and the building could be built in any form or shape that people wanted to have. So the first thing is, as I said before, is fragmentation. Second thing is to make the people who design buildings believe in some degree of standardization, some degree of regularization, if you like, some degree of science into a art craftsmanship. And so they have to become really much better versed at methodologies and some degree of mathematics. And this is what I see as being serious problems.
So, Alberto, a quick follow-up. Carl, you would like to respond?
I had a question, which was, some areas are more narrow and maybe would offer, you might make more progress in a narrower scope. I was wondering about pole barns. So these are buildings that you can build from designs offered by certain kinds of companies that they can throw up in about, less than a week. And I was wondering if they were simple enough that maybe this vision of the digital design could be done at least for pole barns.
Yeah, well, definitely if you have a simple building, but that's not the challenge, right? So the challenge is to to build big buildings, right?
Okay. So not
so
enough.
that's the reason why, that's where you have the big gains, right? And so that's where people would like to see advances, right? Not in the simple things. They don't pay too much attention to that. And so the challenge is the complexity on one side and the fact that they are afraid. And so, in fact, there is a project in Milano. It's called Milano Innovation District. And that is 1 million square meters to be built from scratch. And this land was given to land lease for 99 years, and they have to populate this very large piece of land. And so since it's nothing there, then we can start exploring the use of these methodologies for at least the first few buildings. Then if it is a failure, they are not going to create a big problem to the company. But if it is indeed successful, is a proof of the concept, and then they plan to replicate everywhere else.
So, Alejandro, Alberto, a quick follow-up for you.
Sure.
We both worked in Singapore, and Singapore is big in digital design. The Punggol Digital District is a big development. That everybody starts with digital twins. But I would like you to focus a little bit on Singapore's public housing scheme. The Housing Development Board owns 1.2 million apartments, and they build thousands of apartments a year. If these folks have not been able to standardize, nobody will be. Okay, so are you familiar with what they're doing? Because there is a level of standardization that they apply. Are you familiar with their work?
Well, they actually, some of that work was done in collaboration with land lease, right?
Sure.
But the problem again is it was too early. There was not enough study on what needs to be standardized. So that was one of the issues that has not been so interesting to develop.
Okay, thank you. Alejandro, I have a question for you. Reflecting on what you presented and what you submitted, distributed energy resources, of course, very important, but they apply fairly awkwardly to the individual homeowner. People are talking about aggregations. They play the role of the utilities. And again, you pose the question, how much data do we need to make them work? What do you think is the biggest challenge right now? Is it regulatory? Is it data availability? Is it the utilities are not playing by the rules? I mean, just what is the biggest challenge for DER leveraging?
I think it's a combination of both. I mean, data availability is definitely an issue. I mean, at the distribution level, if you want to extract some of these models I was talking about, you need enough resolution, in spatial and temporal resolution of the measurements you are gathering. For example, inside the household, if you are trying to distinguish among appliances and so on in terms of utilizing them to provide regulation services and whatnot, you need some also data to characterize those and use them in your learning algorithms and so on. So that's part of the issue, data availability. Then regulatory, I would say more is, for example, how do you monetize the services provided by these resources? I mean, at the bulk level, provision of services is basically, I mean, companies can monetize that, and there is a market for that. But at the distribution level, there is no such a thing, right? Yet. So it's in many places. So it's a combination of those things, I would say.
So just a quick follow-up. We many of us do quite a bit of research and emerging schemes of consumer aggregations, storage as a service, and many of these things. And we always say in our papers, well, the regulations do not allow that now, right? But maybe sometime in the future. What would it take for the regulators to become a little bit more inspired and more general and more permissive. So various innovating schemes can apply there. Have you seen any movement in the marketplace in that direction, or what drives it?
I have known, but my guess is that if there is sufficient proof that leveraging these technologies at the grid edge and so on provide the benefits that are expected, especially as I was saying, when you go to large integration of renewables, where you are no longer going to have like large generators providing these services. I think that's what probably would make them move. I mean, of course, there is always the concern of reliability. I mean, the power industry is relatively, I would say, they are conservative in terms of changes and so on, and for a good reason, right? So reliability is an issue. So if you can show basically that that's going to improve reliability, or at least not make it worse, I think that things would start changing probably.
Thank you, Alejandro. I have asked before the panelists to look for some common theme, because when I saw the three presentations, they seem disconnected. Of course, we're dealing with the same problem, this elephant and the blind people, right? And Carl suggested perhaps a common thing is to reflect on the pace of innovation. And as technologists, as regulators, we have the opportunity to accelerate or decelerate pace. And maybe I can ask for anybody in the audience, the panelists or anybody, what technology do you think need to be accelerated at this point? And maybe you can reflect to what technologies maybe should wait a little bit until policy and other things catch up. But let's start with things that you could all benefit if they can move faster. Since Carl, since you mentioned that, maybe you can reflect on this first.
I would say some resolution or something to make us with greater clarity about a balance between wireline and wireless communications. So, for example, with the power grid, there was an interest in using the power lines in the house to do communications, but that didn't work out. And now we have a raft of new wireless technologies like UWB that might be useful in the home. And so I don't still have clarity as to when I should be building a house with a bunch of wires in it, and when I should be instead focusing my attention on accommodating the wireless system.
So that will be a standardization or some kind of consensus by the industry that you'll be looking for?
Yeah, I was thinking more of a kind of, I was thinking kind of commercially, like you just decided it's like the putting the communication wires in is unimportant because you've got enough of it covered with the wireless system, or the opposite, which is that you should be trying as hard as you can to put in, as much as things on the wireline system as you can, because it's more reliable and it can be put in cheaply at the beginning. And so.
Good. Alejandro, your thoughts on that? What technologies do you think are the bottleneck right now and should put an effort to accelerate them?
I mean, I would say that inside the households, DC versus AC, right? So what do I mean by that? I mean, most of the loads we have inside a household are DC, right? I mean, computers, TVs, etc. Yet the distribution system is AC. So in new construction, I could see the benefits of just having a rectifier at the feet of the house and then basically moving all the loads to be in DC, so you don't have this AC to DC and so on power transformation that you need to do. I mean, of course, there are challenges in terms of protection. I mean, clearing faults in DC circuits is harder and so on, but I think that that could change things quite a bit.
Indeed, and that doesn't sound like so much of a technology challenge. We know how to do DC, right? And all of the lighting has gone DC anyway because it's LED. It's also an industry consensus and availability of products and codes and so on that will get us there. if I understand it.
Yeah. Exactly, but you are right. I mean, this lighting, I mean, it's all DC these days, right? But you have that extra AC to DC transformation that you wouldn't need if it would be a DC distribution system. So, yeah.
Alberto, your thoughts on that? What technologies right now are the bottleneck?
Well, everything. I mean, thing that is the combination of the technology which are the bottleneck, I think. It's not a single technology, it's a multiple point of failure. And so it's the capability of putting different technology together, is integration. That's my point. Okay,
so now knowing that I'm speaking to a bunch of technology, what technology should we slow down and wait? Because it's too early for it. I never had to answer this question, myself, right? Everything was shiny and amazing, right? But seriously, is there anything that we should be doing less of, waiting for something else to happen first?
In my opinion, for example, well, it's not slowing down, but changing is, for example, the ventilation in view of the pandemics. So we should
sure. Adaptability. That's a good point.
Right, yes.
Carl?
One that has come up lately that I thought might be premature, the Biden administration asked NIST to come up with a labeling system for IoT devices. And so, if you look at the device and it's rated for, security at medium high and, power efficiency at high or whatever. So the labels, I mean, they were asked to have the labels for security considerations. But I worried about this because security is an emergent property of an environment, and that depends on the environment. And I don't think we understand what the environment will be for these IoT devices well enough to know what kind of tags would be reasonable. So you might have a tag saying component A and component B are both secure, each one of them individually. But when you put them together, they're not secure. And so until we have some kind of framework for compositional treatment of security properties that can be reflected in the tags, it may be premature to have tags.
Very good. So going back perhaps to Alberto's standardization, modularization, and APIs, right? So you can have a framework to deal with all these issues. I'm looking at the clock and we are past our allotted time. I don't want to keep people any longer than necessary. I found this presentation very stimulating. I'm grateful to all the presenters in the panel and the panel discussion. And all of it has been recorded and has been archived, and you can access it by presentation if you want, and we'll be sharing those links shortly. So again, thank you all for presenting. Thank you for attending, and we'll stay in touch. Maybe you can pull something together that is more uniform next time we get together. Thanks so much.
Thank you.
Thank you. Bye-bye. Thank you all.